than all these real professionals, so you'll have to bear with me. So I'm going to be talking about additive manufacturing from the perspective of sort of the individual or the hobbyist or maybe the entrepreneur that's just getting started. For us, additive manufacturing is kind of a big deal. Manufacturing, as a lot of the other presenters touched on, is sort of traditionally understood from these huge manufacturing processes that are generally unique. And for us, what we can do now is you can have just a regular, a smaller shop, and you can have like, so for example, Technocopia has a wood shop. And we use a lot of traditional manufacturing, where you start with something, you remove your wood from it, and then you have what's left. But now, and those take, each process that you use uses a completely novel sort of tool or process. With additive manufacturing, you're seeing now a single tool, like a 3D printer, being able to do a huge gambit of different parts and pieces that sort of change what's available at the lowest levels of engineering and design. And a lot of this got touched on from some of the other speakers in terms of what it means for prototyping and sort of iterative design. But I think some of the cooler parts of this movement is maybe not so much in the actual what's now possible, which is a big deal. But this is also coming at a time where, so now we have this 3D printing sort of opening up what's possible in terms of being produced, but we also have sort of a rethinking of the way we distribute information and the knowledge of how you would do something. So 3D printing has exploded in the context of sort of the open source movement. And now, now we're sort of fashioning ourselves as part of this maker movement, which is sort of further embodying the idea of passing around information and understanding the knowledge necessary to how something works, how it's produced, and then how you would recreate those sort of processes in a way that you can do. Technocopia sort of isn't your home garage, but it's supposed to approximate that. And so, this is what's possible for each individual to do at home, and that you don't necessarily have to go out and have someone, you don't have to go to the Walmart or whatever your region has to be able to get the products that you need. I think this slide's sort of extraneous with some of the stuff that everyone else has covered, but our 3D printing basics is faster prototyping development. It's less wasteful. So you're not starting with a block of metal and leaving it a bunch of it on the floor, or you're not starting with a block of wood and turning half of it into sawdust. A ubiquitous tool, so one 3D printer can print a huge array, but it also means sort of more generally that a single file can be passed around, and anyone with sort of any 3D printer, of which there's a huge array, can now print the same part on different machines with slightly different processes, but you still get the same part. So I can print something here in Massachusetts that's the same part that can be printed in, say, Egypt. And then you can have these sort of ludicrous international design teams that aren't slowed down by sort of shipping lanes or having to move around. You can have the same prototype showing up in multiple labs around the world. And we've been fortunate enough at Technocopia that we've had some of these sort of novel interactions. We've had designers coming out of like Brazil jumping on a project for just a few months because it was an open source project. They could get started with us by popping out our prototypes on their machines at their own facilities. And you see some of this coming up again in like a MIT established Fab Lab standard, and that's sort of in that same envelope of what you can produce in one certified Fab Lab is producible all the way across the spectrum. There's not a lot of cons, but they should be noted. There's not like what Stratus was talking about. Of how like not all of the processes are up to snuff yet. Like you can't just do anything you want yet. But a lot of these new materials, like with what Voxel 8's putting out, is like it's mostly a factor of time, and then we'll have sort of almost everything at our fingertips in terms of what's possible in additive manufacturing. But so on. In terms of a more deeper sort of look at what additive manufacturing does, it sort of blows the doors off of what we can do in terms of spinning up young companies. A lot of the costs, and if you look at a lot of the investment markets, .com companies are a great return. There's relatively low costs. There's not a lot of spin up necessary. The product that they're producing doesn't have a lot of materials or things that need to go into it. But the return on investment for these .com companies is huge. You can do and investors see these companies as very lucrative opportunities, whereas manufacturing is much harder to get investment for. Because there's a lot of spin up, there's a lot of costs associated with starting in manufacturing, a lot of time goes into the development of these products. But with the open source movement sort of changing the way we develop products and the way we pass around information and what products are available to people, the new additive manufacturing machinery, and then sort of at a larger scope, the digital manufacturing tools allows us to get closer to open source hardware. So this is stuff that you see where you go on like a Thingiverse and you have a whole bunch of the blueprints available just sort of floating around, and you can grab, instead of going to Walmart to get your a coat hanger, you grab a design file that's free on the internet, and then you now have this piece of hardware that's sort of a uniform thing that anyone can have. So what this does is it changes the way we sort of manufacture stuff. It brings manufacturing hard goods sort of towards a similar model of the way we develop software, in that you can have a lot of iterations, international projects, very low costs in terms of developing. Sorry, I don't do a lot of public speaking.
You're doing great, Nick. You're doing great.
No worries. But and we see now that the cost of hardware is sort of dropping pretty quickly, developing hardware in these new ecosystems. So at our space, we're able to develop, huge projects. Most of our designs, if not intended to be sort of forever produced on these machines, we've done years of prototyping before we ever bring a product to market that was all developed just with 3D printing in-house. And, there's no, and the costs are coming down actually really quickly. At a larger look, the maker movement's really sort of pushing the envelope in terms of sort of opening what's possible in terms of the free parts of the economy. With the internet, we're able to sort of pass around skills and know-how, and that sort of transcends with being able to produce software and hardware that also sort of mix with that movement really well. And then makerspaces are part of that as sort of a focal point. And this is where a lot of the neat innovation comes from. So we've talked a lot today about how we have incubators and accelerators and all these co-working spaces throwing a bunch of people from disparate backgrounds, possibly not even non-engineering backgrounds, which one of the advantages I like to say that we have as a makerspace versus maybe some of the more specialized incubators is that we have artists that use our machinery for art, but they sort of aren't from that paradigm of engineering process where they're thinking in like 1, 2, 3, 4, 5 sort of steps of engineering. But what we'll have is someone will come and try to really just push the machines to the edges of what's possible and what they're capable of doing. And then we'll have engineers being part of this process, learning maybe not from sort of the dogmatic engineering perspective, but more from an innovative perspective, thinking out of the box. And that comes from sort of very uniquely having so many different viewpoints and different sort of processes and styles of thinking about things all in one house, and then making those resources available so that people can just sort of play with things and play with ideas and how that happens. But now, thinking of it in the same level with the open source software, passing around that understanding and knowledge, and now with these new types of manufacturing, open hardware, you can be having these conversations both in your local space, but also with other places in your own country, but across the whole world. So we have projects that we've worked on with, folks in Boston, but also, Egypt, Spain, and then also Brazil. We've had so I'm also a worker owner of Neurorobotics Cooperative, so that's where some of these projects I'm referencing are coming from. So this is one example of an open source project called WikiHouse. I would imagine a lot of you guys are probably already familiar. But this is a open source project to build sort of structures generally, but homes. It's part of this idea of so this blueprint, this house, this hardware, all of it's free. So the know-how to understand how to make this product, the designs for the robots, so this is sort of built on your sort of standard 4x8 CNC mill, wood cutting mill. They use the standard 4x8 plywood board, and they sort of IKEA cookie cutter it into sort of a prefab house that you can just sort of slap together. And they have a lot of modular designs. But you have this sort of open community now where people are contributing huge sections. So someone might design a new archway that could be used in different applications. Someone might design a ramp or a staircase or a door frame or a window holder.